So here's the 6 trig functions when we know the coordinates of a point. Okay. Sine y over r, cosecant then would be r over y. Cosine x over r, secant r over x, tangent y over x, and cotangent x over y. Does not matter where it's at. That's always the situation. Now, I've always talked about it and explained it as far as graphing it, and I'm actually going to do that as we do this example. But basically, that's all you have to do is all I need to do is find the hypotenuse and filament. So you might want to put them on your note card at some point in time. Okay. So the first thing we need to do is find the value of r here. So r equals the square root of x squared plus y squared. So in this case, that's the square root of 4 plus 1 or 5. So since we have the point 2, negative 1, we're talking about this point here, 2, negative 1. Oops, 2 negative 1's over here. Okay. We're basically talking about that point right there. So what we're doing is we have a right triangle then that's going to go from here to here. Right? That's almost a right triangle. Right? But here's the thing, that my triangle I draw, the vertical side always goes from the point to the x-axis. Okay? The vertical side of the triangle always goes from the point to the x-axis. In other words, whenever we do this, it's going to look like this then. That I'm going to have, regardless of where my point is, my triangles are always going to look like this. Okay? They're always going to make that bow tie, butterfly type look. Okay? That you'll notice that I never went to the y-axis. Okay? We go from the origin to the point to the x-axis. So here's the point. So if this is my point here, 2, negative 1 then this is always where my theta, my angle is. My angle is always here in those spots. So that means then that the y, here's y and here's x. So y and x. So the vertical part of the triangle is always y. The horizontal part of the triangle is always x. Okay. So to find the 6 trig functions here, then we just need to plug them in. So sine of theta is equal to y over r. And yes, I am going to allow you to leave the radicals in the denominator. Okay. Now, I expect that you will do sine and then cosecant next to it, even though I didn't do that on the quiz, so that it would, just to see if you're paying attention. So cosine is always x over the hypotenuse. So secant would be the reciprocal of that, hypotenuse over x. Oh, they just asked for sine, cosine, tangent. That's all right, I'm doing all of them anyway. Okay. Tangent, y over x, negative 1/2. So even though they didn't ask for it, we'll put them down there anyway. Okay. So the triangle matters as far as where the point is, but to find the answer to a problem like this, you just need to use those ratios. Put x where it needs to go, put y where it needs to go, and put r where it needs to go. Okay, so the unit circle. All right, so you might want to take this out. All right, and we're going to use the fact that we have cosine is x over r, sine y over r, tangent y over x in some of our developing of the unit circle. Okay. And here's the things. We're going to name the quadrants. We're going to put the angles in degrees, the angles in radians, the coordinates of sine, cosine, and tangent, and then we're going to talk about the domain and the range of all three of them too. Okay. All right, so we're going to start with the quadrants. So what are the four quadrants we have? How do I label them? Okay, so they're 1, 2, 3, and 4, but where does it start and how does it go? Okay, so we've got 1, 2, 3, and 4. Okay, all right, there's our four quadrants. Okay, now let's talk about points for a moment. Okay, or the signs of them. So in the first quadrant, we have we've just declared that x and y go with sine and cosine, right? Or cosine and sine. Okay. So really what we're going to do is our points that we have here are going to be that each point is going to be, it's going to be cosine, sine, and then tangent is going to be on the outside. Okay. So as we have them written here, we'll always are going to have, it'll always look like this. It'll always look like cosine of theta, sine of theta, and tangent of theta. Okay. All right, so inside the parentheses is always sine, is cosine then sine. Outside is tangent. All right. Now, let's think about the first quadrant. In the first quadrant, x and y have what sign? Okay, they're both positive. Okay, so I'm going to have positive, positive, and then if tangent is y divided by x, what's the sign of tangent going to be then? Positive, because if I divide two positives, I get a positive. Okay? How about in the second quadrant then? What are x, y, and... Okay, negative, positive, and then when I divide those two, I get a negative number. Okay? How about the third quadrant then? Okay. They're both negative in, right? X and y are both negative. And what do I get when I divide two negatives? Positive. Okay. Right. And the fourth quadrant? Positive and negative inside the parentheses, and so I divide them and I get a negative. Now that's important because that's going to help us determine the signs of everything else. Now the other thing is we looked at the other day, you looked at some triangles. We looked at 30, 60, 90, and we looked at 45, 45, 90 right triangles. So we had a 30, 60, and 90 right triangle, which that was 1, 2, and the square root of 3, right? Okay, this is the triangle. This will help you if you know this triangle. 45 degree angle there, then it's 1, 1, and the square root of 2. Because everything on the unit circle then uses those two triangles to find the measures, okay, or to find the coordinates. So we actually are going to use them. Okay. All right, so let's go at it right now then. So let's start with the simplest parts. Okay? This is called the unit circle because the radius is 1. Okay? 1. So that means that the coordinates of, and we're gonna start there just for a second. the coordinates of this point here at, oh, let's do degrees, I'm sorry. Here's 0 degrees here, right? Okay, and I'm going to put degrees on the inside, and then we're going to put radians around the outside of the circle. Okay, all right. Inside the circle, but radians towards the center, or degrees towards the center and radians towards the outside. Okay, so it's 0 degrees here. If I go all the way around, I end up at 360, right? Okay. Halfway is 180. Okay. If I go a quarter of the way, it's what? 90. All right. And 3/4 is 270. Okay. Now, in making the unit circle, I'm going to use fractions to do it. Okay? I'm going to divide this big piece of pie I have here into parts. And the thing is that those parts go with these two triangles completely. So, if we look at it, we have here, I'm dividing this circle into, actually I'm just going to take the top half of the circle, and I just divided it into how many pieces? How many pieces do I have there? 6 pieces, okay? And so if I take 180 degrees and divide it by 6, what do I get? 30, right? Okay. So each of these parts are divided by 30 degrees, right? So then the first one would be 30 degrees. When I add the 30, I get 60. 60 plus 30 is 90, plus 30 is 120, plus 30 is 180, and then keep working your way around. Okay? So we have, so I'm going to get rid of them. No, I'll leave them there. So we've got 30, 60, we did 90, 120, 150, 180, and then we just keep going. What's after 180 then? 210, right? Okay. Then 240, 270, 300, and 330. 330. Okay. So we've just divided the top half of that triangle, or of the unit circle, into 6 parts, which each of those 6 parts is 30 degrees. Okay. So that helps us to fill those numbers in correctly. Okay. Hopefully. All right. Now, if I take and I cut each part in half, oops, not there, here. Okay. Now what did I just do with the top half of it? Okay, I cut it into 4 pieces. And if we take 180 divided by 4, which is the same as 90 divided by 2, what do we get? 45. So each of those halfway points is going to be 45 degrees. So we have 45. And then add 45 to that, we get 90. 90 plus 45 is 135. 135 plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315. And then add 45, we get 360. Okay? So all I did is just use fractions to be able to do that. Okay? And when we do the radians, we're going to do the same thing. Okay? Which we're going to do now. Okay? So let's go back to let's talk about radians now. All right, let's use blue for radians. Okay? Now, for the radians, how far is it all the way around the circle in radians? 2 pi. Okay, so I have 2 pi here. Okay, just on the inside of my circle. And which means that halfway around would be what? Pi. Okay, so, and we talked about that with our conversion from radians to degrees, that pi and 180 are equal to each other. Okay. So 90 degrees would be what? What? Pi over 2, because it's half the distance from 0 to pi. And so 270 then would be 3 pi over 2. Right? We talked about that yesterday when we were talking about revolutions, okay, going around the circle. Okay. Now let's go back to the green again. Okay. Our green lines divided the top half of the circle into how many pieces again? 6. Okay. So if the top half of the circle has a length of pi, and I divide it into 6, how much is each piece then? Okay, 1/6 pi, or pi over 6. So that means then at 30 degrees I have pi over 6. Okay, or 1/6 pi. Okay. Well, if I take 1/6 and I add 1/6, what do I have? 2/6. And 2/6 reduces to 1/3. So this is pi over 3. Okay. And if I add another 6, so I have 2/6 and then 3/6, well, 3/6 is 1/2. Okay. Right. And then I go to the next green one, I get 4/6, and 4/6 is 2/3, so 2 pi over 3. And then the next green line would be 5 pi over 6. So all I'm doing is adding by 1/6 all the way around. Okay. So we add one more, we get 6 over 6, which is 1. Add one more, we get 7 over 6. Add another one, we get 8 over 6, which is 4/3. Add another one, we get 9 over 6, 3/2. Then 10 over 6, which is 5/3. And 11 over 6. Oops. And then 12 over 6 would be 2 pi. Okay? All right? So if I divide it like that, and think about it fractions-wise, I can go through it. Now, if you know the degrees, you know how to convert degrees to radians also, don't you? So you could use a conversion. It would just take an awful long time to do that. Okay? All right, let's talk about our dotted orange lines then. Okay? We divided pi into how many pieces there? With the orange ones? Into 4 pieces, right? Okay? So that means each one is going to be 1/4. Okay? So we have pi over 4. So there's 1/4. We move to pi over 2, and that's 1/2. Okay, that's 2/4. So the next one then would be 3/4, 3 pi over 4. And then pi would be 4 over 4, which is 1. Then 5 over 4. 6 over 4, and 7 over 4. Okay. So there's our degrees and radians. Okay. Really not that difficult, right? As long as you think about how we've divided it up. Okay. All right, so now let's talk about the points, the coordinates. Let's use the green here. Okay. Now, we said that the unit circle has a radius of 1. So what is the coordinate of this point right here at 0 degrees? Okay, the x value is 1, the y value is 0. Okay, so we have the point 1, 0. And these are actual values, okay? When we start writing the other ones in, it's because those are actually the coordinates of those points. All right? What about at 90 degrees? What is it? 0, 1. Okay? And at 180? negative 1, 0. 270, 0, negative 1. Okay? All right, so we're going to do the cosine and sine first, and then we'll come back and do tangent. Okay, so let's go to 30 degrees. So we look at this 30, 60, 90 right triangle. Okay, 30 degrees. The cosine of 30 degrees is the adjacent over hypotenuse, so square root of 3 over 2. Okay, the sine of 30 degrees is opposite over a hypotenuse, 1/2. So we have x is square root of 3 over 2, y is 1/2. Okay, just from the 30, 60, 90 right triangle. Okay. Well, what happens at 60 degrees compared to 30 degrees? What's the difference? Okay, from 30 degrees to 60 degrees, what's different? Okay, yeah, the adjacent side and the opposite side switch, don't they? Which means then that cosine and sine are going to switch. Okay. So that means it's going to be 1/2 square root of 3 over 2. Okay. All right. 45 degrees then. Okay. Well, they're both the same, aren't they? Okay. They both equal 1 over the square root of 2, but we're not going to use that. We're going to use what? Square root of 2 over 2. Okay. All right, when I simplify that. Okay. As I multiply both the numerator and the denominator by square root of 2, and we'll get the square root of 2 over 2. So these are both square root of 2 over 2. Now, okay, the first number here is x, right? The second number is y. Okay, let's look at the second quadrant. The second quadrant says that x is negative and y is positive. So we're going to think about reflections. Right? If I take this first quadrant here and I reflect it over the y-axis, okay, then that means that these two numbers here, oops, oh, don't do that. There we go. That each of the coordinates are actually just going to flip over and be at the same spot, because 150 degrees is how far from 180? 30. Okay, so whatever the 30-degree angle numbers are here, I'm going to use them over here. I'm just changing the sign. Okay. Same with 45 and 135. Same with 60 and 120. So all I have to do in the second quadrant then is make the x values negative. Y values are still positive. So to find all of the rest of them, to do the rest of the unit circle, we're just using reflections then. So now I can take the top half of the circle and I can reflect it down over the x-axis for the bottom half of the circle. Okay. So how far is 210 from 180? 30 degrees. So that means I'm going to use the one that's 30 degrees from 180 up here, right? So I'm still using square root of 3 over 2 and 1/2. It's just in the third quadrant, they're both going to be negative. Okay. In the last couple times I've done this, the third quadrant is where people have messed up. They switch the numbers for 210 and 240. Okay. And here's the thing to think about, okay? Is that which one's farther from the origin? Is x or y farther from the origin here? Okay? And think about that as far as the lengths are concerned. Okay. All right. The fourth quadrant, same way then. But we have x is positive, y is negative. So we have negative square root of 3 over 2, positive 1/2 at 330. Oops, excuse me. That should be positive and negative. Sorry. Negative 1/2. And square root of 2 over 2, negative square root of 2 over 2, 1/2, and negative square root of 3 over 2. Okay. And there's our cosine and sine. So this whole thing, oh my gosh, we're running out of time. This whole thing is determined by the first quadrant. If I know the first quadrant, I can do the rest. Okay, so let's finish up. Okay, at 30 degrees, tangent is square root of 3 over 3. At 45, it's 1. And at 60, it's square root of 3. And then it's just a matter of changing the signs in the other quadrants, okay, appropriately. But let's look at the axis, okay? Tangent is y over x, okay? So if I take 0 and divide by 1, what do I get? 0, okay? But if I do at 90, if I do 1 divided by 0, what do I get? Undefined, because we can't divide by 0. This is undefined. Okay. At 180, we have 0 divided by negative 1, which is 0. And at 270, we have negative 1 divided by 0, which is undefined. Okay? And then it's just a matter of changing the signs. Negative square root of 3, negative 1, negative square root of 3 over 3. These are positive in the third quadrant. And then negative again in the fourth quadrant. But still, if you can memorize the first quadrant, as far as those are concerned, everything else from there is reflections. Just a matter of changing the signs.